Okay. Hi everybody, this is Courtney, Doug, Matt, and Ben. We did our presentation on Apollo 13 geared towards 4th grade students. We did our presentation in Nearpod, and we used audio files to expand on our bullet points throughout the lesson. We used videos from YouTube. We also did an interactive moon activity where the students can actually go through and move around the moon and see the different space landings for them to explore. Our quizzes, we have the climb quiz. We used fill in the blank, open-ended questions, multiple choice, just to give a variety to gear towards all of the students' different learning styles. And at the end of the presentation, we assigned the students a research project where they'll work in partners or small groups to research Apollo 13 on their own. Then they would create a poster board, and then they create a 5-minute flip grid where they explain what they learned, show their poster board, and then the students can watch 2 other groups' videos and comment on their projects. So that's all at the end. We are going to be skipping through our videos, so you don't have to watch our 6-minute YouTube videos just for the sake of time. Okay, so we have our lesson objectives, just everything that the students are going to learn. So the goals for today's lesson are to learn about the missions to the moon, to learn about main events of the Apollo 13 mission, and identify terms related to space travel.
Hi friends, today we're going to be learning about Apollo 13. You're probably wondering, what is Apollo 13? And no, it's not a video game. Apollo 13 was a space mission that went to the moon. It launched April 11th of 1970. It was the 3rd moon landing mission. However, it never actually landed on the moon, which you will learn more about later on. The spacecraft that they went to the moon in was made up of 2 independent spacecraft. One was called the Orbiter Odyssey, and the other was the Lander Aquarius. These 2 spacecraft were joined together by a tunnel so that the astronauts could move around in both spacecraft. The mission itself was for the spacecraft to land on the moon. Then they were going to demonstrate their landing precision, which means that they were going to be able to land accurately and in a very exact spot. That way they would have more time that they could explore the area and collect samples on specific sites on the moon. Here we have the astronauts who went on Apollo 13 mission to the moon. We have Jim Lovell, who's 42 at the time. We have Jack Swigert, who was 38, and we have Fred Hayes, who was 35 years old. All 3 men trained for many, many years and prepared to go on this mission to the moon. On the next slide, we're going to watch a video of the actual launch.
And like I said, we're going to skip through the YouTube video just for the sake of time.
Now we are going to do a time to climb activity where we'll test some of your knowledge on how the Apollo 13 mission started.
So as time to climb activity shows up on students' individual screens, they join the lesson using a unique name. Students will slowly roll into the lobby and music will begin to play as they start to receive questions on their devices. As students join the lobby, they're getting ready to be tested on what they have learned in the beginning of the unit.
So this is just a recap of what we know so far. Houston, we have a problem. Routinely scheduled maintenance turns into something big. Quick fact, astronaut Ken Mattingly was replaced by Jack Swigert due to a case for rubella and was working in conjunction with Mission Control and with lead flight director Gene Kranz when the call from the Apollo 13 crew came in. Houston, we have a problem. This was in response to an on-ground Mission Control member telling an Apollo 13 crew member to stir tanks for routine maintenance. So next we have a video detailing that exact scenario where the Mission Control member told Apollo 13 crew member to stir the tanks, and listen carefully to find out what type of tanks were stirred. Now we have an open-ended question that goes over that. Question is, what type of tanks needed to be stirred, which led to the main explosion and further led to a chain reaction of problems for the remainder of the mission? Houston, we have a problem. Continued. Issues and possible remedies. The solving of every problem often led to the discovery of a new problem, due to the fact that many of these scenarios were never predicted nor tested on the ground. The routine stirring of the oxygen tanks led to a limited amount of oxygen being available after a malfunction and small explosion that happened. And it was found in a later investigation that the material known as Teflon was used within the tanks and was known as a combustible material. Houston, we have a problem. Continued. The astronauts need oxygen and power. The incident with the oxygen tanks led to a malfunction in the oxygen supply and power supply. Oxygen, which was needed to breathe and for generating electricity, was slowly running out after the explosion in some of the oxygen tanks. This required shutting down power and conserving oxygen to save what they had left. Both were needed later due to the mission being extended in the total number of days because of the incident and time needed to fix the issues. The turning off and conservation of power had never been done before and certainly wasn't intended to take place in space, which led to several other issues. Houston, we have a problem. Continued. An assortment of newly created issues. Some of the other issues included but were not limited to temperature issues for the astronauts, water condensation inside the command module, lunar module supporting 3 men for 4 days when it was only intended to hold 2 men, and the need for a plan to restart power and re-engage the rocket boosters briefly when the time came to travel back home. They would also need to use the moon's gravitational pull in order to get a head start and slingshot around the moon before a previously unscheduled burn of rocket fuel could be used, which would help orient the spacecraft back on course with Earth. Houston, we have a problem. Continued. There was an issue with the crew breathing in their old breath, carbon dioxide, CO2, which led to a united effort of intelligent minds from the Mission Control Room and from the crew of Apollo 13 needed to solve the problems of adapting the cartridges of carbon dioxide removal system to make it work again. They did so by using random materials on board to adapt the cartridges in order to remove the CO2. It was a monumental problem-solving and critical thinking task. Many of the issues that the astronauts faced lasted well past the loop around the moon.
Let's explore the moon landing missions. On the next slide, you will see a moon that you can click on and rotate to see where many missions have landed on the moon. See what you notice about these missions.
So at this stage, the students will be able to view a visual model of the moon. They can rotate the model around and click on different parts of it to look at different missions.
Now it's time to think, pair, share. Turn to your shoulder partner and discuss these key questions. After exploring the moon on the NASA website, what did you notice that was interesting? Was there a dot for the Apollo 13 mission? Why or why not? After you've discussed these questions with your partner, we will rejoin as a class and discuss them as a whole class. After experiencing so many problems, the astronauts were still in trouble. Now they had to make a loop around the moon. The ship became a lifeboat, a vessel to carry the astronauts to safety after they were unable to land on the moon. To return home safely, the ship would have to swing around the moon rather than take a shorter path home, turning before reaching the moon. With the sun as a guide, the spacecraft used a 5-minute engine burn to loop around the moon before turning off the power to conserve the ship's energy. The loop around the moon took over 2 hours.
And now the students will view footage that was recreated of the loop around the moon. So they'll see a visual image of the moon recreated footage.
Now it was time for the journey home. Because the flight lasted 2 days longer than expected, the cruise ship was quickly losing power. To save power, the crew turned off all power supplies on the ship which were not essential to flying. Temperatures dropped to 38 degrees Fahrenheit, nearly freezing. Brrr. The crew had to ration food and water so that they could make it home safely. The trip home took 3 long days as the crew used the Earth to align their trajectory. Finally, on April 17, 1970, the spacecraft re-entered Earth's atmosphere. NASA, worried the ship's heat shields were damaged during the mission's various problems, feared the spacecraft and the astronauts would not survive the re-entry to Earth. As the Apollo 13 crew approached Earth's surface, parachutes deployed and the astronauts safely landed in the Pacific Ocean.
So here's a video of that re-entry. They had to come in at a specific angle, and it's a video of them safely coming in, being picked up by Navy personnel, and the celebration that followed.
This is what we learned about the mission of Apollo 13. To come out of it, numerous design changes were made to the Apollo service module and the command module so that subsequent missions would be more successful. These include removing all the cryotank fans and wiring, removing the thermostat from the cryotanks and changing the type of heater tube, adding a 400 amp hour lunar module, descent stage battery. What happened next? There were some of the things that happened after the mission to the astronauts. So astronaut Hayes went back with NASA, and he was assigned to command the Apollo 19 moon mission. However, that mission and 2 other missions were canceled after their budget was cut. So he later piloted the Space Shuttle Enterprise during its test flights. In 1982, Swigert was elected into Congress in his home state of Colorado. However, he was diagnosed with bone cancer and passed away before he could be sworn in. In 1994, Lavelle and a couple journalists, one being Jeffrey Kluger, co-wrote a book about his spacecraft type missions and his career. Primarily, the book focused around the events of the Apollo 13 mission. If you want to read it, it's called Lost Moon, The Perilous Voyage of Apollo 13. And in 1995, it spurred the movie of Apollo 13, which kind of details the events occurred of Apollo 13. Next would be a fill in the blank that the kids would take just to remind them of some of the things they learned throughout the little presentation, just to assess what they know. It's pretty easy. Next would be a quiz they took. Now this quiz is assessing the whole lesson. So we have questions ranging from the beginning of the lesson to the end of the lesson, all around. And the students would just choose out of multiple choice and get the right answers. So now this was the project that we talked about a little bit at the beginning. It is the students' turn to research Apollo 13. First, they will find a partner that they wish to work with. They will then research a little bit about Apollo 13 together, and what they come up with, they will then create a poster with what they have found or what interests them about the Apollo 13 mission. And then they will, using that poster and the knowledge they know, they'll create a Flipgrid to then share the poster with the class and teach the class what they have learned. And then they will also see the other kids and learn something from them, hopefully, and then comment or respond to two other groups' Flipgrids, detailing what they liked, what they learned, what they found interesting, and basically anything they want to comment on the other students.
So thank you for joining us on this lesson of Apollo 13.